Hi, I'm Carly McAvoy, and today we're doing Lesson 8 for Math 064, which is the second shot at division. We already did division with a single-digit divisor, and now we're going to do it with a double-digit or even triple-digit divisors. And it is hard, and you need practice. So practice watching me, practice the problems that I practice, do the worksheet practice, and then practice more, ask your instructor for more help until you really feel like you have the process down. Remember, whenever you're doing division, you can check it by multiplication, so you don't have to wonder if I got that right. And when you do division on a calculator, it gives you a decimal answer, and so we're looking for you to keep not having a decimal answer, but keep your answer with a remainder. Have you put it in fraction form or the R form. And so the calculator is good for some things, but when you're doing long division and you don't want decimal remainders, then you have to be able to do it a different way. So that's why you want to be able to check it. I'm just going to refresh really quickly on the terminology that you need to answer the first 5 questions on the Division 2 practice worksheet. If you're adding, then these things are called add-ins. And the answer is called a sum. If you're subtracting, then the top number is the minuend. The bottom number, or the one that you're subtracting, you're taking away there, is subtrahend. The answer is the difference. If you're multiplying, these numbers that you're multiplying together are called factors. And the answer is called a product. And then, of course, if you're dividing, you have a lot of terms. You have a divisor, you have a dividend, you have the quotient, you have the remainder. And then for all of these, I'm going to use red to circle the operator. The operators are addition, subtraction, multiplication, and division. So the operators are those things that tell you to actually perform an operation. And the equivalent symbols, and all these are the lines. There's no equivalent symbol in the division problem. The division bar in itself indicates the operator and the equal sign, really. So you should be able to know all those terms. We've gone through all those now, and there's a refresher. Sort of a refresher assignment on that in the first part. And after that, we're going to jump right into doing some long division. I'm not going to do the exact problems that are on your page because I want you to have more to practice. You practice the ones on your page, and then we'll do the ones, some similar ones on here. First, I want to remind you about these. These two things are not equal. They don't mean the same thing. One of them is undefined and one of them is 0. And hopefully by now you've started to get that. One of the clues that I gave you yesterday was under is undefined. When the 0 is under, that means it's an undefined expression. We cannot divide by 0, so this would be undefined. And I want you to use that word and not like can't be done, impossible, or whatever. When you have 0 divided by 35, what you're saying is how many times would 35 go into 0? And the answer is 0. It doesn't go. So that's two different things, and those things keep cropping up because it's important that 35 divided by 0 thing comes up and people forget about it. So I want to keep reminding you about that. Okay, we're going to start off doing a problem, and I'm just making this one up. So can't say whether it'll actually come out to be equal or not, but I want to show you a process. Let's say I'm dividing 9,658 by 17. You know those times tables that you had? Well, you have them, usually they go up to 10, sometimes people make them to 11, even 12, but you don't go up to 17. And I don't have the 17 tables memorized either. So I'm starting off saying, well, I know for sure 17 doesn't go into 9. Okay, but I don't know how many times 17 goes into 96. And so here's where we really start to guess and check. But I can make logical guesses a little bit. What I'm going to do is round 17 to the nearest 10, which is 20. I'm going to round 96 to the nearest 100, which is 100. And then I say, how many times would 20 go into 100? So what I'm doing here is I'm asking myself, instead of 17, I'm saying 20, because that's rounded to the nearest 10. And instead of 96, I'm looking at 100, and I'm asking myself, how many times would 20 go into 100? And that would go 5 times, because 2 goes into 10 5 times. So that's what I'm going to start with as my guess. So I come over here and say, well, what would 17 times 5 be? If you're lucky enough to have these in your head, fantastic. I'm just not. 7 times 5 is 35. 1 times 5 is 5 plus 3 is 8. That's 85. And so I think that's right. I think that 17 would go into 96 5 times. So I'm going to write 5 up here. And 17 times 5 is 85, so that goes down here. Now when I subtract, I get 11. So good. I never want to get it down here. I never want to get something that's bigger than up here. That means it should have gone another time. But next thing I'm going to do is bring down my 5. And now I'm asking, well, how many times would 17 go into 115? Well, again, if I round 17 to the 10s, I have 20. If I round 115 to the hundreds, I have 100 again. So I would guess 5, but I can see that 5 that I did last time looked like not enough. So what I'm going to do is guess 6. And I'm going to say, what is 6 times 17? One thing you can do is just take 85 and add 17 again. That would be another one. But I'm just going to start from scratch. 7 times 6 is 42. 6 plus 4 is 102. And that looks like the right choice. So I'm going to say 6 times 17 is 102. Remember, when I subtract here, I never want to get anything that's 17 or more. So when I take 5 minus 2, I get 3, and I get 13. And now I'm ready to bring down the 8. Now I want to say, well, how many times would 17 go into 138? Now my rounding is really getting less and less helpful, right? Because 138 would also round to 100. How many times does 20 go into 105 times? Obviously it goes more than that. In fact, I think it's more than 6. So I'm going to go ahead and say, what about 17 times 7? These are all just guesses over here, and I kind of see what I get. 7 times 7 is 49. 1 times 7 is 7, plus 4 is 11. So I'm going to say, oh, I think that looks pretty good. I'm going to go 7 times 17. That's 119. Now when I subtract 18 minus 9, I get 9. And I had to borrow here to make that happen, so I have 2. 2 minus 1 is 1. Oh, here's a problem. I can't subtract and get more than I had up there. What does that mean? What that means is that 17 should have gone into 138 another time. So my guess of 7 wasn't very good. So I'm going to rejigger this. This is what I want to say to you. It doesn't have to be that you get it right the first time. You just need to get it right the last time. So I have 138. That was not good. I'm going to try 17 times 8. 8 times 7 is 56. 1 times 8 is 8, plus 5 is 13. 136 looks like a nice thing because 8 times 17 is 136. And when I subtract that, I get 2. Now I know 17 doesn't go into 2. So that would be my remainder. And remember, I can write it as a remainder of 2, and some instructors may want you to do it that way. But I know for the test that you have to get into Math 90, they always say put them in fraction form. So that's what I'm going to do is 2 over 17. Okay, so now I want to check it. Over here on the right are all my guesses. And I just left them up because sometimes you might want to go back and use the same number again and you've got those all multiplied out. Okay, so how I'm going to check this is I'm going to take my quotient, which is the answer, times my divisor, which is the number on the outside there, and I'm going to multiply those together. 7 times 8 is 56. 7 times 6 is 42, plus 5 is 47. 7 times 5 is 35, plus 4 is 39. Then I'm multiplying by 10. It looks like a 1, but it's in the tens place, so I put a 0 there. And I have 8, 6, 5. Now when I add those together, carrying when appropriate, I get 9,656, and then I add my remainder. And that gives me 8, 5, 6, 9. That gives me 9,658, and that is my dividend. And as long as I multiply and add the remainder and get the dividend, then I know that I did that correctly. So there's an example with a 2-digit divisor, and the reason it's harder is because those numbers are harder to work with. So I'm going to show you something that some people think is an easier way to go and some don't. Okay, let's clear this and do another one. Sometimes your problems are written in different format. For instance, you might have the problem ask you to divide 8,931 divided by 21. And so you have to rewrite that into the correct format to do the problem. And so remember, the correct format is the dividend that goes first in this format goes underneath when you rewrite it. 8,931 divided by 21. So what we did last time was we tried 17 times 5, 17 times 6, 17 times 7, 17 times 8. We kept trying and seeing which one of those works. One thing you can do is to write down the multiplication facts before you start. And then you have them and you don't have to keep doing that off to the side. 1 times 21 is 21. 21 times 2 is twice that, which is 42. 21 times 3 is 21 more than that, which is 63. 21 times 4 is 21 more than that, which is 84. 21 times 5 is 21 more than that, which is 105. 21 times 6 is 21 more than that, which is 126. 21 times 7 is 21 more than that, which is 147. 21 times 8 is 21 more than that, which is 168. I should have left space for 21 times 9, but I ran out of the space. I'm going to write it right over here. 21 times 9 is 21 more than that, which is 189. So I was just adding 21, and I could do that in my head. If you can't do it in your head, you can do it off the side. But here's all the numbers now for 21. So now I can maybe do this without having to do stuff off to the side. So let's take a look. 21 doesn't go into 8. Would 21 go into 89? We'll come over here. 21 times 5 is 105. That's too much. but 21 times 4 is 84. That's the one we want. So I'm going to say 4 times 21, and that is 84. So writing those out in advance saves me some time there. Some people think it takes more time to do that than to do it as you need it. I've done it both ways. You can decide what works for you. 9 minus 4 is 5, and then I bring the next number down, which is 3. The next thing I'm asking is how many times would 21 go into 53? If I come over here, 21 times 3 is 63. That's too much. So 21 times 2 is 42, and that's the one that I want. 3 minus 2 is 1. 5 minus 4 is also 1. And then I'm going to bring the 1 down. Next, I want to know how many times would 21 go into 111, and that would be 5, because 21 times 6 is too much. So 21 times 5 is what I'm after, which is 105. And when I subtract, I have to borrow, and that gives me 6. That is the remainder, because 21 doesn't go into 6. So I have 6 over 21. Now I'm going to check that by multiplying my quotient times my divisor. Remember, 20 is actually in the 2 is actually in the tens place, which makes it 20, so I put a 0 there. 2 times 5 is 10, 2 times 2 is 4, and 1 is 5, 2 times 4 is 8. Maybe you noticed how quickly I did that row where I'm multiplying by 1. Multiplying by 1, remember, is the multiplicative identity. Multiplying 1 doesn't change it, so I knew it would be 425, so I could just write that down really quickly. Adding these up, I get 5, 2, 9, 8. And I add on my remainder, which was 6. That gives me 8,931. And what I'm looking for is that my dividend, look, 8,931 was my dividend. This is my check. I feel confident that that's the correct answer then is 425 and 6 remaining out of 21. And this was just, I did this over here, and a lot of it I didn't need, but it didn't take me that long, and then I had those to look at, and it kind of helps me decide what numbers to use. So I put it out there as a suggestion to you. Let's see another one. You have 6, I think, division problems to do. We've done 3 of those 6. They can be a little bit more complicated when they get to be 3 digits. So let's take a look at a 3-digit one. Let's say I'm going to divide by 103. And I'm dividing 20,674 by 103. So first of all, I need to rewrite that into correct division form for me to do the problem. So that's going to look like 20674 divided by 103. Again, you can write your problem off to the side and write the first 9 of the 103. If that's hard, then don't do it. I'm going to do it. I'm not going to do 1 times 103 because I think people know what 1 times 103 is 103. So let me do it this way. 2 times 103 is 206. 3 times 103 is another 103 added on to that, which would be 309. 4 times 103 is 103 added on to that again. It's 412. 5 times 103, 103 added on to that again is 515. 6 times 103 is 103 added on to that again, and that makes 618. Notice that we're jumping up by 3, 6, 9, 12, 15, 18, because we're adding that 3 on the end, and at the beginning we have a pattern, so it gets a little easier to do if you can recognize the pattern. which means the next one we go up to 718 will go to 21 because we're adding 3 onto that. 8 times 103, we're going to go to 8 and then 24. And 9 times 103, we're going to go to 9 and 27. I have all the possibilities that I want to choose except for one, and I know 103 times 1 is still 103, so I didn't write that one, but I have all these other options up there. Okay, so 103 does not go into 2. 103 does not go into 20. 103 into 206. So 103 goes into 206 exactly 2 times. So my 2 goes over here. It doesn't go over the 2 or the 0 because 103 didn't go into 2 or 20. It goes into 206. So that's where I'm going to put that first one. Okay, 2 times 103 is 206. And then I'm going to subtract, there's nothing left. I'm going to bring down the 7. How many times does 103 go into 7? 0 times. I chose this problem for a reason. I picked these numbers because I wanted you to have an experience where you get zeros, and then people like kind of freak out on those zeros, right? Look, if I bring something down, I have to put something up. Let's go to the next number, bring down the 4. How many times does 103 go into 74? It doesn't, so that's 0. I don't have any more numbers to bring down. So, that's my remainder, 74 over 103. It's okay to get zeros in your answer. It's okay to have 2 zeros. I could have 5 zeros in a row maybe. The thing is, I did all this work over here multiplying out the 103 and I didn't really need it. I didn't know what I was going to need. You don't always know either, but you have to remember when something comes down, something has to go up. Let's do our check on this one. 200 times 103. You know, it doesn't really matter which number you put first. You have to multiply those two things. So I'm going to do this because remember that shortcut? When you're multiplying with something with a bunch of zeros, all you have to do is drop those zeros straight down. 2 times 3 is 6, 2 times 0 is 0, and 1 times 2 is 2. Then I'm going to add on my remainder, which was 74. And that is my dividend. And so I know that I got that right with my check. 274 over 103. I did do that so we would encounter zeros, because you do get zeros in your answers. So be ready for that. Okay, the next kind of problem that you have on your page is something like this. It says, find the quotient of 4,251 and 52. I am changing the numbers that you can have a different experience but have also the practice with me. So when I say the word quotient, then what follows, the first number that follows is the dividend always, and the second number that follows is the divisor. If I wanted to write this in fraction form, it would look like this. The first number would go on top, just like we would read top to bottom, and the second number on the bottom. But how I want to work this problem is a division problem like this. So I'm going to do this divided by 52. When I see this problem, I know for sure there's going to be a remainder. Sometimes when you divide, there is no remainder. I know for sure there's going to be a remainder because 52 is an even number. Even number, odd numbers, you're familiar with those. Even numbers end in 0, 2, 4, 6, and 8. Any even number I ever have as a divisor only goes into even numbers evenly. That's a mouthful. even numbers never go into odd numbers without a remainder. We're going to count by 52s and do our list of possibilities over here, and you're going to see that all of them end in even numbers. Whereas the last page we did, when we have something that ends in an odd number, didn't we have, yeah, 103 was odd number. We had 6, and then we had 9, and then we had 12, and then we had 15, so it goes even, odd, even, odd, even, odd. Evens only ever make evens. So I know for sure I'm going to have a remainder in this problem. 1 times 52 is 52, so I'm just going to start with 2 times 52, which is 104. 3 times 52, whoops, didn't. Sometimes when you're talking and writing, your brain doesn't sync up. I'm going to add 52 to that, I'm going to get 156. 4 times 52, I'm going to add 52, and that's a little harder. You can do that on paper off to the side. I don't have that much space on the board to do that, so I'm going to do it in my head. But adding 52, I would get 8, and then I would get 208. 5 times 52, we're going to add 52, and I'm going to add the 52 gives me 10, 260. 6 times 52, add 52, you get 312. 7 times 52, add 52, you get 364. 8 times 52, add 52, you get 416. 9 times 52, add 52, you get 568. So if you look at the numbers 4, 6, 8, 0, 2, 4, 6, 8, we never get an odd number. So I can count forever with 52 and I'm never going to hit an odd number, and so I know that this isn't going to go evenly. Okay, so let's take a look at this. 52 does not go into 4. 52 does not go into 42. 52 into 425. Look down this list. 9 is too many. 8's just right. So we're going to say 8. 8 times 52 is 416. And then we subtract. 15 minus 6, I'm sorry, is 9. And 1 minus 1 is 0. And I'm going to bring down the next number, which is a 1. How many times does 52 go into 91? Well, look, even 2 52s is too much. So it just goes one time. And borrowing, 11 minus 2 is 9, and 8 minus 5 is 3, so we get 39. So that's my remainder, and again, I'm going to write it as a fraction, 39 over 52. That's what I think my answer is. I could do this. Quotient is 81 and 39 over 52. But how do I know for sure I didn't make a mistake? Maybe multiply something wrong, maybe added something wrong over here. I don't know. How I'm going to feel confident is to do the check. And I keep pushing this because I want you to do that. The quotient times the divisor, 2, 16, put a 0, 5, and 8 times 5 is 40. Add it straight down, you get 4,212, and then I'm going to add my remainder, which was 39. Remember, you're adding, when you're adding or subtracting, you're always lining things up. 9, 10, 11, 3, 4, 5, and I get 4,251, which is the dividend that I started with. That's how I know confidently that I did this correctly, because I did the check. All right? Let's do one more. Remember, it doesn't matter if you're dividing by 1 digit, 2 digit, 3 digit, 4 digit, 105 digit. The process is the same for division. And you get good at the process by just doing it over and over and over. I wish there was just ways that could avoid some of that, but you really can't. Okay, We're going to do 95,345 divided by 15. And I'm going to write out my 15 multiplication tables over here. Oops, I didn't need to do that one, but it's already up there. 1 times 15, add 15 more is 30, add 15 more is 45, add 15 more is 60, whoops, add 15 more is 75, add 15 more is 90, add 15 more is 105, add 15 more is 120, add 15 more, 135. So it doesn't take me very long to write those. That's why I like this method and I'm just doing it. But I also know that some people don't want to do that. You want to just guess and check as you go through like I did on the first example. Ask your teacher which way they prefer and have them help you, and you can decide which way you like. You might decide you like this or not. 15 does not go into 9, but I know it would go into 95. Looking over here, 7 is too much, but 6 is right on because 6 is 90. So I just want to point out too, 15 is an odd number, and if you look at the multiples of 15, 15, 30, 45, 60, again, odd, even, odd, even, odd, even. Odd numbers always have that pattern. Even numbers always have a pattern of all even. Okay, so I'm going to subtract. I get 5 and bring the 3 down. Get 53. 15 times 4 is too much, so 15 times 3 is what we're after, which is 45. Now when I subtract 45 from 53, I get 8, and I bring down my next number, which is 4. Looking down the list here, 84, well 6 is too much, but 5 would be just right because it's 75. Now I'm subtracting, borrowing here, 14 minus 5 is 9, and bring down the 5, get 95. 15 times 6 is 90. Just about ran out of space, and I've got 5, and 15 does not go into 5, so therefore I have 5 over 15 remaining. So what I want to say to you is you don't always get a remainder. Sometimes something goes in there evenly, but I'm practicing remainders because those are usually the harder cases, but I have something that goes exact. Now I'm going to check this always because I really think you find mistakes, and it's a good practice to do this. 6, 3, 5, 6 times 15. 6 times 5 is 30. 5 times 5 is 25, plus 3 is 28. 15 and 2 is 17. 6 times 5 is 30 plus 1. And now I'm going to multiply everything by 1. I have 6, 5, 3, 6. Adding straight down, I get 95,340, and then I add my remainder. And I check to see that my answer down here is exactly the dividend that I started off with. 95,345, yes. Now I feel like I checked it. I know that my answer then, I'm going to call it Q for quotient, 6,356 and 5/15. That is my answer. All right, so that's a bunch of division practice. We're also going to look at word problems with division, And those, of course, are a little harder. So I try, when I'm doing these, I use different numbers for some of these problems, but then when it comes to the word problems, I try to read through them with you, because word problems are harder, and so you should maybe read the problem through with me, but then pause the video and try the word problem on your own. Let's see what we got here. The first 5 were to label the different parts of these problems using those terms that we looked at. And then we have 6, there's 3, and 3 more division problems. And then we get into word problems. The makers of the new Chevy Volt claim that you can travel 380 miles on a full electrical charge and a full tank of gas. So you have both, you're charged up and you're gassed up, you can go 380 miles. Okay? Derek found on MapQuest that the distance from Independence, Missouri to Ketchikan, Alaska is 2,616 miles. If he plans to take a round-trip vacation from Independence to Ketchikan driving a Chevy Volt, how many times would he have to recharge and fill his tank? If you have a remainder, round to the nearest whole number. Okay, so couple things here. He's not just driving to Ketchikan. He's driving to Ketchikan and he's driving back. So do you see that the distance that we have there, the number 2,616, that's only half of our distance? We're going to need to double that before we do anything else. Okay? So 2,616 doubled. I can double that by adding it to itself or by multiplying by 2. 2 times 6 is 12. 3, 12. 5,232 represents the number of miles for the round trip. So what's happening in this picture? Let's say this is Independence, Missouri. He's starting off. Over here is Ketchikan, Alaska. And as he drives, he's chugging along. Dun, 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 dun. Up 380 miles later, he needs to recharge and refuel. Then he goes along again, da, 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 uh-oh, 380 miles later, he needs to recharge and refuel. Da, 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 da. Oh, here we go, 380 miles later, he needs to recharge and refuel. And that keeps happening all the way to Ketchikan and all the way back. So if you look at that picture, this is what I'm seeing in my head, is we want to see how many times that mileage is divided up into 380 mile chunks. Because that's what's happening, is after 300 miles, he's got to stop and recharge and regas. Okay, so we're dividing. If you can visualize it, if you don't see a keyword, at least you can visualize in there. Okay, so we're really asking the question, how many tanks per trip? And when you say the word per, that's a division thing usually. All right, so we're going to take 5,232 and we're going to divide by 380. Okay, and you can use the thing that I do where you write the numbers off to the side, or you can guess and check as you go. Let's start by guessing and checking and seeing if we get into trouble. 380 does not go into 5, it does not go into 2, but it goes into 532. It doesn't go into 52, I should say, but it does go into 532. So how many times? Well, 380 just goes one time in there. If you double 380, you get 760, right? That's too much. So we're just going to go one time. 1 times 380, and then subtract. So when I subtract, I get 3, 4, 143, and then I bring down the next number there. So for this one, well, I'm going to guess. I'm going to say this is 380 is about 400. This is my guess and check method that we did in the first one way earlier. And 1432 is about, well, I'm going to round to the 100, and I'm going to say it's about 1400. How many times is 4 going to 14? Just 3 times. So I'm going to guess it's either 3 or 4, and I feel like it's probably going to be 4. So let me go over here and do 380 times 4 and see what I get. I get 0, 12, 13, 14, 15. That's too much, right? So my guess of 3 would have been better. 380 times 3 is 1,140. So I've got 3, 1,140. Now I'm going to subtract. 2 minus 0 is 2. And 13 minus 4 is 9. 3 minus 1 is 2. So then I've got this remainder, because 380 doesn't go into that. But what this means is that if he was driving along, he went to catch a can, now he's on his way back, he's 292 miles from home. There's 292 miles left. So can he stop, or does he need to refuel and recharge again? Sure, he needs to redo it again. Maybe he's got enough fuel and recharge now to get to work and back after his vacation. He's going to have some left over, but he's going to have to charge that again. So in the problem, it says round your answer to the nearest whole number. This 292 is more than half of 380. So we would round up to 14. So for instance, if I had 1 and 7/10, I would say, well, 7 is more than half of 10. So this would be approximately, remember the approximate sign I talked about? We would round up to about 2. So when you're rounding a fraction, what you're asking is my number more than a half or less than a half? And if it's more than a half, then you round up. So for this problem, he's got half of 380 would be like 190. 292 is way more than half. So we would say, rounding up, he would need 14 times to refill and recharge his car to make it to Alaska and back. Okay. Let's see what the next problem looks like. According to simplyhired.com, the average salary for an auto mechanic is $36,000. If a mechanic works 40 hours a week for 49 weeks of the year, what is his or her average hourly wage? I really had a hard time saying that. His average hourly wage. So why didn't he work 52? There's 52 weeks in a year. Well, people get vacation. So let's say that this person got 3 weeks of vacation. So they worked 49 weeks, and every week that they worked 40 hours. And then they made $36,000 altogether. So figure out how many hours they work in a year first. So how would I do that? If I know that they worked 49 weeks, 40 hours a week, I can figure out their total hours, 49 times 40. There's more than one way to do this problem. If you see a different way, or if you did it a different way but got the right answer, hallelujah. It's just like going from your house to the grocery store. There's more than one way. There's one way that you get used to doing it, and so you do it that route every time. Same thing for me. There's ways I get used to doing problems, and I tend to do it that way. But maybe your fresh approach is better or different. At least it's okay for you, and then you keep doing it. So 49 weeks and 40 hours a week. Multiplying those, bring that 0 straight down. That's 1960, which means that this person works 1,960 hours in a year. And now we want to know what the average hourly pay is. Once you're saying average, it's a division thing. And you're finding the average of something, you add up everything and then you divide. Well, they already added up his pay with $36,000, so we didn't have to do that. But we are dividing by his hours. So we take 36,000, that's what they said in the problem, that that the average pay was. And then we divide by 1,960. Okay. So, again, I could count by 1960s, or I could kind of see how it goes. How many times does 1960 go into 3? None. 36? None. 360? None. 3,600? Okay, finally it will go into that. What do I run around this into? This is about 2,000, this is about 4,000, so it looks like maybe it could go twice. But I'm going to check that. I think it's going to go twice, so that's why I'm multiplying by 2, and if I'm wrong, then I'll drop down to 1. 18, 19. 3,920 is too much. So it just goes one time. So, 1. Now I'm going to subtract 0. This is 5. So 4. This is 15. So 6. 1,640, and then I bring my 0 down. So this is a big number. How many times does 1960 go into that? Well, I'm going to round 1960 up to 2,000 in my head, sort of. I'm writing to show you what's happening in my head. And 16,400, I'm going to round just to 16,000. Whoops, I put 16,400, but I was supposedly rounding this, so I'm kind of estimating how many times I think it will go. That would be 16,000. 2 goes into 16 8 times. So I think it's 8. I should probably check that. I could do it right there in the problem, but I'm going to do it over off here to the side. 8 times 0 is 0. This is 48. 72 and 4 is 76. And that's 15,680. That would definitely go in there. So 8 times that is 15,680. And then I'm subtracting, I have zeros. 2, this I borrowed from to make 3. 13 is 7. This was 5. So 720. 18 and 720 over 1960. Well, let's see what my question said about rounding, or what I need to try to do to that. Round your answer to the nearest dollar if needed. It wouldn't be needed if it came out to be exact, but ours didn't come to be exact. 1720, so either I want to say that they make $18 an hour or they make $19 an hour. I want you to round it to the nearest whole number. And so what you want to do is look at your 720 out of 1960 and ask yourself, is that more than or less than half of 1960? And you could divide 1960 in half to see what that would be. Or you might just have a sense of it. If you divide this by 2, 2 goes into 19 9 times, and 2 goes into 16 8 times, and so 980 would be half, and we're less than half then. 720 is less than half, so we would just say, oh, they make about $18 an hour. Might be $18.30 or something like that, but to the nearest dollar, they make about $18 an hour. And I looked it up on the internet and actually found that it was, the Bureau of Labor Statistics say that, they're talking about middle of the range mechanics. Some make way more, some make a little less. They're making $17.25 or something like that. So we're pretty close, about $18 an hour for a mechanic. Okay, according to ehow.com, the highest paid welders were self-employed and had a salary of $90,300. Welders working for publicly traded companies had an average salary of $31,099, and welders working for the federal government had the lowest salary at $24,417. Find the average of these three salaries rounded to the nearest dollar. So when you want to find an average, you add the three amounts up and then you divide by 3. So 90,300, I don't think I'm going to remember all these. Oh, I've got it written down here. That's good. I've got print out of the paper, which you should have also. Every time you sit down to work through it or watch a video, you should have this printed off so you can check it yourself. Okay, so what we have to find the average is we add up the amounts we were given. 90,300, 31,099, and 24,417. First thing you do is just add those three amounts up. This is finding the average. 9 and 7 is 16. 9 and 2 is 11. 7, 8. 5. 9 and 3 is 12, 13, 14. So when I add these up, I get 145,816. And now I just take that amount and I divide by the number of things I added, or the number of add-ins, and that was 3. 3 doesn't go into 1, but it goes into 14 4 times. Multiplying by 4, we get 12. 3 goes into 25, because we brought the 5 down. Goes 8 times. 8 times 3 is 24. Subtract. Bring your 8 down. 3 goes into 18 6 times. That's exactly 18. Bring your next number down, your 1. 3 doesn't go into 1, but because you brought something down, you have to put something up. It goes in there 0 times. Then bring down your 6. 3 goes into 16 5 times. 5 times 3 is 15, and so we get a remainder of 1/3. Is 1/3 closer to the 605, or would it be closer to 606? Because it asks you to round to the nearest dollar. Well, 1/3 is less than a half. So we would round it and say the average salary for these guys is or women is $48,605. That's what a welder can look at if you look at all the people making the lowest and the highest. Now, is that accurate? No, it doesn't really mean anybody's making that amount, but the average for those three amounts is $48,605. Quite a range of salary choices in there. Okay, let's look at the next word problem. Again, read the problem, try it on your own, come back. All right, on the Comcast.net website, they say that the average starting salary for a horticulturist is $37,200. while the average mid-career salary is $53,400. If a person worked 11 years to raise their salary from that starting pay up to that mid-career pay, and they got equal raises every year that they worked, how much of a raise in dollars did they get every year? So we're dividing the raises up equally into equal parts. That's how we know it's dividing. But first, we need to see how much of an increase it was from when they started until they were at their mid-career range. So $53,400 is their, after 11 years, that's what they're making, $53,400. But they started at $37,200. So after 11 years, they had seen a raise of $16,200 over the course of 11 years. The question is, if you divide that up into equal parts for each year, how much of a raise would that be every year? Their average raise, really. So 16,200 divided by the 11 years that they were working there. 11 goes into 16 one time. The 11s are so nice because 22, 33, 44, 55, 66, very easy to track those. So 55 is too much, 44 would be our choice. So 4 times 11 is 44. gives you 8. Bring down your 0. 11 goes into 80 7 times, because that would be 77. That gives you 3 when you borrow here. And then 11 goes into 30 2 times. And that gives you 8. And so you have 8 over 11. The question is, does 8/11, so is that closer to going up to 73 or staying at 72? Well, is 8 more than half of 11? Half of 11 would be like between 5 and 6, right? So 8 is a little more than half, so we're going to round that up. So it looks like this person got raises of about $1,473 a year. One of the things on that math test that you're going to take to get into Math 90 is they do ask you to look at a fraction and saying, should this go up or down, like looking at whether it's half or not. So it's nice to do that, practice these in the word problems, because that'll be a skill that you need. Okay, that's division 2. Again, division takes a lot of practice if you're not good at it yet, because you haven't practiced it enough. Keep practicing and you will get better. You can go online and find division worksheets. I went on and found them just to check it out, but I just typed in division worksheets, and there's a bunch of them you can practice online or get some from your teacher. Okay, have a great day, and we'll see you next time.